Hello dear students, all of you welcome to Vidyan classes. It is the second lecture on function in the chapter relations and functions. Today we will discuss important memory tips in lecture number 1 which are used in lecture number 2 and problem discussion on injective, surjective and bijective functions. Important memory tips in lecture number 1. First, if f so that a to b be a function, then if f so that a to b is a function, then domain of f is equal to, shortly written as dom f is equal to a set. A is equal to the domain of f. It is the first point. Second, codomain of f. B is equal to the codomain of f. Third point, range of f, which is shortly written as RNGF, which is same as RF. That is equal to set of all images, that is equal to collection of y so that xy belongs to f. If f so that a to b be a function, then domain of f means that is capital A. Codomain of f is capital B. Range of f, set of all images. X is the object and y is the image. When f operates on x, gives the image that is y. F acts as mirror, x is the object and y is the image. When f operates on the object x, gives the image y. Set of all images is called range. Clear? A function f so that a to b is called 1 1 or injective a function f so that a to b is called 1 1 or injective if for every two elements x1 x2 belongs to capital A, for every x1 x2 belongs to capital A, fx1 is equal to fx2 implies x1 is equal to x2, or x1 not equal to x2, that implies fx1 not equal to fx2. That means for any two elements x1, x2 belongs to domain set, fx1 is equal to fx2. That means two images are same, implies objects are same. Images are same, implies objects are same. Objects are not equal, implies images are not equal. Then the function f is called injective or 1, 1. Most important, a function f so that a to b is called 1, 1 or injective if for every x1, x2 belongs to capital A, fx1 equal to fx2, that implies x1 equal to x2. Images are equal, objects are equal. Objects are unequal, images are unequal. Clear? Third point. A function f so that a to b is equal to a function f so that a to b is called surjective. A function f so that a to b is called surjective or onto. If range of f, which is same as RNGF, is equal to RF, is equal to B. What is B? B is the codomain of f. If range of f is equal to codomain of f, that is codomain of f. If range of f is equal to b, that means codomain of f, then the function f so that a to b is called onto or surjective. Second definition, or for every y belongs to capital B, that is codomains of f. For every y belongs to capital B, there exists at least an element in capital A. For every y belongs to capital B, there exists at least an element in capital A, so that fx is equal to y. This and this are the definition of surjective or onto. For every y belongs to capital B, there exists at least an element in capital A, so that fx is equal to y, so that f so that a to b is onto or surjective. For every y belongs to capital B, there exists at least an element in capital A, so that fx is equal to y, so that f the function f defined from a to b is onto or surjective. Fourth point, a function F so that A to B is called bijective if a function f so that A to B is called bijective if it is both injective, that means 1 and surjective, that is one and on two. Here a function f so that A to B is equal to bijective if it is both injective and surjective, that means 1 and on two. These are most important memory tips to solve the problems in lecture number 2. Clear? Clear? Note down. Note down. Next, elements of mathematics, class 12. Examine each of the following functions if it is injective, surjective, bijective, none of the three. Question number 3, first bit. A, f so that real set to real set, fx equal to s square. We have to test the function defined by is injective or surjective or bijective or none of the three. Solution: f so that real set to real set, fx is equal to s square. Test for injective. What is the definition of injective? For every x1, x2 belongs to domain of f, so that fx1 equal to fx2, that implies x1 is equal to x2. For every x1, x2 belongs to A means real set R. Fx1 is equal to fx2. That implies fx equal to s square, fx1 is equal to x1 square, fx2 is equal to s2 square. That implies x1 is equal to plus or minus x2. Now we have x1, x2 belongs to real set, fx1 is equal to fx2, that implies x1 is equal to plus or minus x2. That means the function does not satisfy the definition of injective. F does not satisfy the definition of injective. Therefore, F is not injective. F does not satisfy the definition of injective, therefore F is not injective. For example, F minus 1 is equal to F plus 1. Fx is equal to s square is equal to 1. It is x1, it is x2. Implies s minus 1 not equal to 1. Fx1 equal to fx2, x1 is equal to plus or minus of x2. Therefore, F is not injective. Test for surjective. Test for surjective. What is the definition of a surjective? What is the definition of a surjective? If range of f is equal to codomain of f, then the function is said to be surjective. Fx is equal to s square is the equation of parabola. Passing through origin and symmetric to y-axis. Fx equal to s square or y equal to s square is the equation of parabola passing through origin and symmetry to y-axis. It is the equation of a parabola y is equal to fx is equal to s square. For x is equal to 1, y is equal to 1. For x is equal to minus 1, x is equal to 1, x is equal to minus 1. Y is also 1. It is a many one into function. Many elements of R correspond to one element. Minus 1 gives 1, plus 1 gives 1. What is the range? The range of f. That means collection. Range means collection of all second members of the order pair. That means y. Y starts 0. Close bracket 0 to infinity. Is not equal to codomain set. That is the real set. Range of f is not equal to real set. Therefore, f is not surjective. In general, f is not injective. F is not surjective. In general, f is not bijective. Therefore, fourth bit, that is none of the three is the correct option to the function defined by f such that R to R, real set to real set, fx is equal to s square. F is not injective, F is not surjective. In general, we can say F is not bijective. So the correct option is none of the three. That is fourth bit. Is the correct option to the function defined by fx equal to real set fx equal to s square. Clear? Clear? Question number 3b. Solution f such that real set to close bracket minus 1 to 1. The function fx is equal to sin x. Test for injective. For every x1, x2 belongs to R. Here A is R. Fx1 is equal to fx2. That means fx equal to sin x, x1 is equal to sin x1, fx2 is equal to sin x2. That implies x1 not equal to x2. For example, fx is equal to sin x, f0 is equal to f pi is equal to 0, but 0 not equal to pi. Therefore, the function defined by does not satisfy the definition of a injective. Therefore, f is not injective. Clear? Next, test for surjective. For surjective, fx is equal to sin x. For all x belongs to R, sin x greater than equal to minus 1, less than equal to plus 1. Since the graph is in this form, it is the graph of sin x. Y is equal to fx is equal to sin x. For all x belongs to R, sin x, the maximum value of sin x is 1 and the minimum value is minus 1. Implies this. A range of f, that is your Rf, is equal to close bracket minus 1, 1, which is same as codomain of f. Of f. If the range is equal to codomain set, then the function is said to be onto. Therefore, f is onto or surjective. In general, examine each of the following function. It is injective, surjective or bijective. Hela. So the correct option is second bit. So the correct option is second bit, that is surjective. So the correct option is surjective. F is not injective, but F is surjective. So the correct option is second bit, that is surjective. Clear? Okay. Next, question number 3C. F such that set of positive real number to positive real number fx is equal to x plus 1 by x, where r plus represent the set of positive real numbers, that is x greater than 0. Solution: F such that set of positive real number to set of positive real number fx is equal to x plus 1 by x. Test for injective. What is the definition of injective? For every x1, x2 belongs to domain of f, so that fx1 equal to fx2, that implies x1 equal to x2. For every x1, x2 belongs to r plus fx1 is equal to fx2. That implies fx is equal to fx1 is equal to fx2, implies this x1 plus 1 by x1 is equal to x2 plus 1 by x2, which implies this x1 minus x2 minus 1 by x2 minus 1 by x1 is equal to 0. Clear? Okay. x1 minus x2 minus x1 minus x2 divided by x1 into x2 is equal to 0. Taking LCM, which implies this x1 minus x2 taking common, it gives 1 minus 1 divided by x1 into x2 is equal to 0, which implies this x1 minus x2 is equal to 0, or 1 minus 1 divided by x1 into x2 is equal to 0. Clear? Suppose it is G star. Star continuing implies this x1 is equal to x2, or one by x1 into x2 is equal to 1, or x1 is equal to 1 by x2. Clear? 1 is equal to 1 by x1 into x2. Now we have for x1, x2 belongs to set of positive real number, fx1 is equal to fx2, that implies x1 is equal to x2, or x1 is equal to 1 by x2. As x1 is equal to 1 by x2 does not satisfy the definition of injective, implies f such that r plus 2 r plus fx is equal to x plus 1 by x is not injective. Is not injective. x1 x2 belongs to R plus, fx1 equal to fx2 implies x1 is equal to x2 or x1 is equal to 1 by x2. As x1 is equal to 1 by x2 does not satisfy the definition of injective, implies the function defined by is not injective. For example, x1 is equal to 2, x2 is equal to half. x1 and x2 are reciprocal to each other. f2 is equal to f half. fx1 is equal to fx2, which is equal to 5 by 2. 2 plus 2 half, that is equal to 5 by 2. Half plus 2, that is equal to 5 by 2. But 2 is equal to x1 not equal to x2 is equal to half. That means 2 not equal to half. For example. So the function defined by is not injective. Test for subjective. For subjective, f so that positive real number to set of positive real number to positive real number. fx is equal to x plus 1 by x. Here x greater than 0. The function f so that a to b is said to be surjective if range of f is equal to b. Here a is equal to r plus and b is r plus. What is the range of this function? Since x greater than 0, root of x is exist. Since x greater than 0, root of x is exist. What is the meaning of this? Its value is real. Root x is real. Now, root of x minus 1 by root of x whole square greater than equal to 0. Root x is exist. Root square of any quantity is greater than or equal to 0. That implies x plus 1 by x minus 2 greater than equal to 0, which implies x plus 1 by x greater than equal to 2, which implies fx is greater than or equal to 2 for all x greater than 0. Clear? Clear? Okay. Implies range of f is equal to close bracket 2 to infinity. Range of f is not equal to r plus. That is a codomain of f. The range of f is not equal to codomain of f, that is r plus. Implies f is not subjective. It is not injective, not subjective. In general, f is not injective, f is not subjective. In general, f is not bijective. Bijective means it is subjective and injective. It is neither injective nor subjective. So in general, f is not bijective. It is not injective, not surjective, not bijective. So, therefore, the correct option is 4. That is none of 3. None of 3 means not injective, not surjective, not bijective. The graph at x equal to 1, the minimum value is 2. Fx is equal to, it is fx is equal to x plus 1 by x. The minimum value of x plus 1 by x is 2 at x equal to 1. What is the range? The range is, that means collection of all images. The minimum value is 2 of y is 2. The minimum value of y is 2. So range of f is close bracket 2 to infinity, which is not equal to codomain. It is the graph of fx equal to x plus 1. The minimum value occurs at x equal to 1. X equal to 1, 1 plus 1, that is equal to 2. The minimum value occurs at x equal to 1. Clear? So the correct option is 4. None of these. None of 3. Clear? Next, question number 3D. The function defined by f such that real set to real set fx equal to sq plus 1. Solution: f such that real set to real set fx is equal to sq plus 1. F such that real set to real set fx is equal to sq plus 1. Test for injective. By the definition, for every x1, x2 belongs to A means domain of f, that is R, set of real number, fx1 is equal to fx2, that implies fx1, that is x1 cube plus 1, x1 cube plus 1, fx2, x2 cube plus 1, cube plus 1. 1 cancel, x1 cube is equal to x2 cube, which implies x1 cube minus x2 cube is equal to 0, which implies x1 minus x2 into x1 square plus x1 into x2 plus x2 square is equal to 0. PQ minus BQ is same as A minus B into A square plus AB plus B square, which implies x1 minus x2 is equal to 0. Since x1 square plus x1 into x2 plus x2 square not equal to 0. For all x1, x2 belongs to real set. It is always true. x1 square plus x1 into x2 plus x2 square not equal to 0 for all x1, x2 belongs to real set. Implies x1 is equal to x2. For every x1, x2 belongs to real set, fx1 is equal to fx2, that implies x1 equal to x2. Now we have we have x1, x2 belongs to real set fx1 is equal to fx2 implies x1 is equal to x2. That is the function defined by satisfies the definition of injective. So F is injective. Clear? Since it is satisfied the definition x1, x2 belongs to R, fx1 equal to fx2, that implies x1 equal to x2, that is the function defined by satisfies the definition of injective. Clear? This satisfies the definition of injective. Test for surjective. Test for surjective. Y is equal to fx is equal to sq plus 1. That implies sq is equal to y minus 1, which implies x is equal to y minus 1 to the power 1 by 3. We have to test the function defined by is surjective or not. By the definition of surjective, for every y belongs to B, there exists at least an element in A so that fx equal to y. By definition of surjective, for every y belongs to B set. B means set of a real number. It is A, it is B. For every y belongs to R, there exists an element. An element means since the function is injective, there exists an element x belongs to A means R, so that fx is equal to f of what is x? X is equal to y minus 1 to the power 1 by 3, which is same as f y minus 1 to the power 1 by 3. Fx is equal to sq plus 1. X is replaced by y minus 1. F is replaced by y minus 1, which is same as y minus 1 to the power 1 by 3 whole to the power 3 plus 1, which is same as y minus 1 plus 1. 3 cancel. which is equal to y. For every, that is f satisfies the definition of surjective. That is f satisfies the definition of surjective. Since for every y belongs to R, there exists an element x belongs to R, so that fx is equal to y. Fx is equal to y. That is f satisfies the definition of surjective. Therefore, f is surjective. Since f is injective and surjective, implies f is bijective. Clear? F satisfies f is injective. First we have injective. F satisfies the definition of injective. Now f is surjective. Since f is injective and surjective, f is bijective. Now it satisfies injective, surjective and bijective. So the correct options are first bit, second bit and third bit. That is injective, surjective and bijective. So the correct options are injective, surjective and bijective. Clear? Clear? Okay, note down. Next, question number 3, bit number E. The function defined by f such that open bracket -1 1 to real set fx is equal to x divided by 1 minus s square. We have to test the function defined by is injective or surjective or bijective or none of the three. Solution: f such that open bracket -1 to 1 to real set fx is equal to x divided by 1 minus s square. Test for injective. Test for injective. For every x1, x2 belongs to open bracket -1 1, fx1 is equal to fx2. That implies fx is equal to this fx1 x1 divided by 1 minus x1 square, x2 divided by 1 minus x2 square. That implies x1 minus x1 x2 square. is equal to x2 minus x1 square x2, which implies this x1 minus x2 plus x1 into x2 this into here it is x1 and minus x2 is equal to 0. Clear? Okay. x1 minus x2 into 1 plus x1 into x2 is equal to 0. Implies x1 minus x2 is equal to 0. Since 1 plus x1 into x2 not equal to 0, which implies this x1 is negative of 1 divided by x2 not equal to. For example, x1 is equal to half belongs to open bracket minus 1 to plus 1. x1 implies this x2 is equal to x1 is not equal to x1 is equal to negative of minus 2 does not belongs to open bracket minus 1 to plus 1. If this equal to 0, 1 plus x1 into x2 equal to 0, x1 is equal to half belongs to this set, since x1 x2 belongs to this set, but x2 if this term equal to 0, x2 is equal to minus 2 does not belongs to this set, so this not equal to 0. If this factor is equal to 0, which is impossible, that means x1 is equal to half, x2 is equal to minus 2 does not belongs to this, which does not satisfy the necessary condition for injective, which implies this x1 is equal to x2. Now we have for every x1 x2 belongs to domain set that is equal to open bracket minus 1 order pair fx1 is equal to fx2, x1 x2 belongs to implies as x1 is equal to x2. For every x1 x2 belongs to open bracket minus 1 fx1 equal to fx2, that implies x1 is equal to x2 is the definition of injective. It is the definition of injective. Therefore, f is injective. For every x1 x2 belongs to this set, fx1 equal to fx2 implies this x1 equal to x2. It is the definition of injective. Therefore, f is injective. Test for surjective. Fx is equal to y is equal to x divided by 1 minus s square. X tends to 1 minus. That means left hand limit of the function at x equal to 1. The value of x is less than 1. Implies y tends to positive infinity. For x tends to 1 minus, y tends to positive infinity. X tends to minus 1 plus. That means right hand limit of the function at x equal to minus 1. Implies this y tends to negative infinity. X is equal to 0 implies y equal to 0. Clear? Implies f is increasing in open bracket minus 1 to plus 1. This line x is equal to 1, this line x is equal to minus 1. It is a x tends to y tends to infinity for x tends to less than 1. Increase of x, y increases to infinity. Decrease of x, decrease of x, y decreases to negative infinity. For x tends to 1 minus, that means at this point y tends to infinity, at this point y tends to minus infinity. It is a 1 0. This is a 0 0. When x tends to 1 minus, y tends to positive. When x tends to minus 1 plus, that means right hand limit at this point, left hand limit at this point tends to positive infinity and tends to negative infinity. At x equal to 0, y is 0. The function is increasing in this interval. Increase of x, y increases. So the function is increasing in this interval. Now range of f which is equal to RNGF, shortly written as RNGF, or which is same as RF is equal to, it is the set of negative real numbers, R minus, it is the set of positive real numbers, union R plus. At x equal to 0, y is 0, union set of 0, which is equal to real set, that is codomain of f. Range of f is equal to codomain of f. That implies f is the surjective. Since f is the injective and surjective, first we have proved f is the injective, f is the surjective. Since f is the injective and surjective, implies f is bijective. The function defined by is injective, surjective and bijective. Therefore, the function f so that open bracket -1 1 to real set fx is equal to fx is equal to x divided by 1 minus s square satisfies the options first injective, second surjective, third bijective. Therefore, the function f so that open bracket -1 to +1 to real set fx is equal to x divided 1 satisfies the options that is injective, surjective and bijective. Clear? Clear? Next, question number 3, bit number f. F so that real set to real set fx equal to bracket of x. Its result is the greatest integer which is less than or equal to x. Solution: f so that real set to real set fx is equal to bracket of x is equal to the greatest integer less than or equal to x. Zero to 1, 1 to 2, 2 to 3, it is the graph of the function fx equal to x bracket. When x varies 0 to 1, its value is 0. When x varies 1 to 2, its value is 1. In 2 to 3, value is 2. In -1 to 0, its value is -1. In -2 to -1, its value is -2. It is the graph of the function fx equal to bracket of x. The result of x bracket is always the greatest integer in an interval. Test for injective. Test for injective or 1 1. For every x1 x2 belongs to domain set, that is equal to R, fx1 is equal to fx2, that implies fx1 is equal to fx is equal to x bracket of x1 is equal to bracket of x2. That implies x1 not equal to x2. Fx x1 x2 belongs to R, fx1 equal to fx2, that implies x1 not equal to x2. Therefore, f is not injective. For example, bracket of half is equal to bracket of 2 1 by 3 is equal to 0. In this interval, bracket of half is equal to 0, bracket of 1 by 3 equal to 0, but 1 by 2 not equal to 1 by 3. Clear? Fx1 equal to fx2, that means bracket of x1 equal to bracket of x2, but x1 not equal to x2. It does not satisfy the definition of injective. Therefore, f is not injective. Test for surjective. Test for surjective. Fx is equal to x bracket, its value is the greatest integer. The greatest integer less than equal to x. Fx equal to x bracket is the greatest integer less than equal to x. So range of, what is the range of this? X belongs to R. The domain set is R. In this interval, the value is 0. In this interval, the value is 1. In this interval, the value is 2. In this interval, the value is minus. In this interval, so range of this is equal to Z set. Range of f is equal to that is set of integers, not equal to codomain set, that is R. So range of f, so range of f is not equal to this. Therefore, f is not surjective. F is not injective and f is not surjective. Since f is not injective and surjective, since f is not injective and surjective, implies f is not bijective. The function is said to be bijective if it is injective and surjective. Here f is not injective and not surjective. F is not injective and not surjective, implies f is not bijective. Therefore, the correct option is the third bit. That means fourth bit. It is the fourth bit. None of the three. The correct option is the fourth bit, that is none of the three. Clear? Clear? Next, question number 3. G. The function defined by f such that real set to real set fx equal to mod of x. F such that real set to real set fx is equal to mod of x. It is the graph of x mod. Y is equal to x and y is equal to minus x. X greater than equal to 0, x less than 0. It is the graph of x mod. X mod is equal to x if x greater than equal to 0, minus x if x less than. It is the definition of x mod. In this interval, x greater than 0, so y equal to x. In this interval, x is less than 0, y is equal to minus x. Since x mod is equal to x, if x greater than equal to 0, x mod is equal to minus x if x less than 0. It is the graph of fx equal to x mod. X greater than equal to 0. X less than 0. For x less than 0, y is equal to x mod, which is equal to minus x. For x greater than equal to 0, y is equal to x mod is equal to x. Test for injective. Test for injective. For every x1, x2 belongs to domain set, that is G R. Fx1 is equal to fx2. So it implies this mod of x1 is equal to mod of x2. That implies x1 not equal to x2. For example, 2 mod is equal to minus 2 mod is equal to 2, but 2 not equal to minus 2. Therefore, the function defined by does not satisfy the definition of injective. Therefore, f is not injective. Test for surjective. F so that real set to real set. Fx is equal to mod of x. Range of f is equal to r plus positive real number. X greater than 0, y is positive. X less than 0, y is also positive. x equal to 0, y is 0. R plus union positive real number union set of 0. Or you can say collection of all x values, y values, range means collection of y values, which is same as collection of y such that y greater than equal to 0, which is not equal to codomain set, that is codomain set is R. Range of f not equal to R. Y belongs to R. Range of f is equal to set of positive real numbers union set of 0, or collection of y belongs to R so that y greater than equal to 0, which is not equal to codomain set. That is codomain of f. It is the domain of f, it is the codomain of. If range of f is equal to codomain of f, then the function is said to be surjective or onto. Therefore, f is not surjective. Since f is neither injective nor surjective, implies f is not bijective. Therefore, the correct option, it is not injective, not surjective, not bijective, none of the, so the correct option is fourth bit, none of the three. Clear? F is not injective. Since it does not satisfy the definition of injective, here range of f is not equal to codomain set. R is the codomain of f, it is not codomain of range of f is not equal to codomain of f. So, R is the codomain of f. Therefore, f is neither injective nor surjective. That is, f is not bijective. So, the correct option is fourth bit. That is none of the three. None of the three. Clear? No doubt. Question number 3. H. The function defined by f such that real set to real set fx is the signum function. We have to test injective, surjective, bijective, none of the three. F such that real set to real set fx is equal to signum x. It is defined by signum x is equal to x mod divided by x is equal to 1 if x greater than 0. If x greater than 0, x mod is equal to x by x is equal to 1. 0 if x is equal to 0. Minus 1 if x less than 0. If x less than 0, x mod is equal to minus x by x is equal to minus 1. Or signum x is equal to x divided by x mod is equal to 1 if x greater than 0, 0 if x equal to 0, and minus 1 if x less than 0. Here it is the definition of signum function. Now we have to test injective, surjective and bijective. Test for injective. For injective, for every x1, x2 belongs to domain set that is equal to R, fx1 is equal to fx2, that implies SGNX1 is equal to SGNX2, implies x1 not equal to x2. For example, since x greater than 0, y is equal to 1. It is the graph of a signum function. X less than 0, y is equal to minus 1. X less than 0. X equal to 0, y equal to 0. It is the graph of signum function. Graph of signum x. F S 2 is equal to S GN3 is equal to dash. For x greater than 0, y is always 1. At x equal to 2, the value is 1. At x equal to 3, the value is 1. But x1 is equal to 2, not equal to 3 is equal to x2. x1 not equal to x2. Clear? Therefore, the function does not satisfy the definition of signum function. Therefore, f is not injective. Clear? It is the definition of a signum function. It is the graph of a signum function. Test for surjective. For surjective function. Fx is equal to signum x is equal to set of 1 if x greater than equal to greater than 0, equal to 0 if x equal to 0, and minus 1 if x less than 0. It is the graph, it is the definition of a signum function. Range of f is equal to Rf, range of f is equal to set of 1, -1, 0, 1. X greater than 0, it is 1, x equal to 0, 0, x less than 0, value is -1. So range of f is -1, 0, 1, which is not equal to codomain of f, that is R. Of range of f is equal to not equal to codomain of f. Implies this f is not surjective. F is not surjective. F is not injective, F is not surjective. Since F is neither injective nor surjective, implies F is not bijective. The range of f is not equal to codomain set, so f is not surjective. Since f is neither injective nor surjective, implies f is not bijective. Therefore, the function defined by as the correct option, is fourth bit, that is none of the three. None of the three. Therefore, the function defined by has the correct option, that is fourth bit, which is equal to none of the three. Here, range of f is equal to set of -1, 0, 1, which is not equal to codomain of f. Therefore, f is not surjective. Since f is neither injective nor surjective, implies this f is not bijective. The function defined by has the correct option, that is fourth bit. Here, the function not injective, since signum 2, signum 3 each has the value 1. Since at 2 value is 1, at 3 value is 1, but 2 not equal to 3, so it is not injective and not surjective. It is the definition of a signum function. It is the graph of a signum function. Clear? Next, question number 3, I. The function defined by f such that real set to real set, f is equal to IDR, that implies identity function on R. Solution, f such that real set to real set, f is equal to IDR, that is identity function on R. It is defined by f is equal to IDR is the collection of excess order pair, so that for all x belongs to R. It is the definition of an identity function. That means x operates on f gives x, or x operates on IDR gives x, implies that fx is equal to IDRX is equal to x. Fx is equal to x. If fx is equal to x, that means y is equal to fx which is equal to y I drx is equal to x. If y equal to x, then the function defined on R is called the identity function. Clear? Graph of IDR, that means y is equal to x, y equal to x is the identity function. This inclination is 45 degree, y is equal to mx, m is equal to 1, that means theta is equal to 45 degree. It is the definition of identity function and it is the definition of identity function. Test for injective. For every x1 x2 belongs to domain, that means R, fx1 is equal to fx2, that implies x1 is equal to x2. Clear? Since fx is equal to x, fx1 is equal to x1, fx2 is equal to x2, fx1 is equal to x1, fx2 is equal to x2, fx1 is equal to fx2, that implies x1 is equal to x2. Therefore, f is injective. Since it satisfies the definition of injective. Clear? Test for surjective. Test for surjective. What is the range of the function? Fx is equal to x. Range x increases to infinity, positive infinity, x decreases to negative infinity. Range of IDR is equal to minus into plus infinity, that is equal to set of a real number which is equal to dash, that is a codomain set. Codomain of f. Since the range of IDR is equal to codomain of f, implies f is surjective. Clear? Since f is injective and surjective implies f is bijective. Therefore, the correct option are first bit injective, second bit surjective, and the third bit bijective. Therefore, the correct options are injective, surjective, and bijective. Range of IDR is equal to R. Since x, the y increases to infinity for x greater than 0, as x increases, y increases. Clear? In this interval, the minimum value of the function is minus infinity. In this interval, the maximum value is plus infinity. That means range of idea is minus infinity to plus infinity, that is lower codomain of f. Clear? Okay, note down. Next question. Question number 6. Give an example of a function which is surjective but not injective. First solution. First bit. F subject. F is a function from A to B. A, B, C. Surjective but not injective. Surjective but not injective. That means many ones on two. F subject A to B is a function. Since it satisfies the definition of a function, the figure shows f satisfies the definition of a function and f is the collection of a x order pair, b x order pair, c y order pair. Here the range of f is equal to B set. That means the function is onto. Since many elements of a correspond to x, it is many one, not injective. Therefore, the function defined by is surjective but not injective. Clear? Clear? Okay. Next, injective but not surjective. Second bit. Second bit. Surjective but not injective. Injective but not surjective. That means 1 1 into function G so that C to D one, two, three, 4, 5, 6, 7, 8 injective. That means 1 1. G so that C to D is a function. G is the collection of 1 4 order pair, 2 5 order pair, 3 8 order pair. Range is the proper subset of D. Range of G is the proper subset of D, so it is not onto. It is also 1. It is satisfied 1 correspond to 4, 2 correspond to 5, 3 correspond to 8, so it is 1 1. Is injective. That means 1 1. Injective, but not surjective. F will be surjective if range of F is equal to B set. Here range of f, that is 4, 5, 8 is not equal to d. F g is a function, C to D, G is injective but not surjective. Third bit, neither injective nor surjective. H is a function, x to y. Neither injective, not 1 1. That means many one, nor surjective. Four, 5, 7, 8, -1, 3, 4, 6. Neither injective, not 1 1. That means many one, nor surjective. Range of f is not equal to y. H so that x to y is a function. Since it satisfies the definition of a function. Many elements of x correspond to 8. H is the collection of 4 8, 5 8, 7 6, is neither injective nor neither injective, since it is many one, not 1 1. So neither injective nor surjective. Range of H is not equal to y. What is the range? 8 6. Range is not equal to y. So it is neither injective nor surjective. Clear? Fourth point, it is bijective. 1 1 and 2. 1 1 and injective and subjective. Injective and subjective. Psi is a function from L to M. It contains, suppose, alpha, beta, gamma, P, Q, R. It is 1 1 also on 2. Psi such that L to M is a function. Since it satisfies the two conditions of a function, psi x, psi is the collection of alpha p, beta q, order pair, and gamma r. Psi is the collection. It satisfies the injective and the surjective. It is 1 1 also on 2. Is injective and surjective. Range of psi is equal to m. Psi is the function defined from L to M. Is injective since it is 1 1. Alpha correspond to P, beta correspond to Q, gamma correspond to R. So it is 1 1. That means injective. Range of f is equal to M. So it is surjective. Is in injective and surjective implies psi is bijective. Here? Okay, note down.